Okay, last lesson we did polynomial operations, and one of those operations was multiplication, and we multiplied doing binomial times a binomial and used the distributive property and ended up with a trinomial usually when we were done. So today what we're going to do is we're going to go reverse of that. So this is called factoring, and there's multiple ways to factor. So to begin with, to kind of refresh a few things to help us with our factoring, first of all, we're going to talk about in our bell work what factor pairs are. So factor pairs of 16 are 1 time, or excuse me, 6 are 1 times 6 and 2 times 3. Those are the two numbers that multiply to give you 6. So those are called factor pairs. So 24, you've got 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And I usually do this in a systematic order to make sure I get them all. So I'll just start with 1 and work my way up until I know I've got them all. And since this end factor pair is 4 times 6, I know I've got them all because 5 times 5 is 25. Okay, 48, I would go 1 times 48, 2 times 24, 3 times 16, 4 times 12, 5 doesn't go into 48, 6 times 8, and I know I've got them all. 7 times 7 would be 49. Okay, and we're going to use that idea of factor pairs here in just a minute. And then remember our multiplying that we did last time. Distributive property, 3x times x is 3x squared. 3x times a negative 2 is minus 6x. A negative 4 times x is minus 4x, and a negative 4 times a negative 2 is plus 8. So we end up with 3x squared minus 10x plus 8. Same thing over here. 7x times x is 7x squared. 7x times a negative 3 is a negative 21x. Negative 6 times x is a negative 6x, and a negative 6 times a negative 3 is plus 18. Combine your like terms. 7x squared minus 27x plus 18. Okay, so like I said, we're going to go in reverse. So this is what we did, was we did multiplying to come up with this trinomial. Now I'm going to give you this trinomial, and we're going to break it down into its two binomials that multiply together. So that's called factoring. So let's see how to do that. Now this right here is just a graphic to help you know where to put your numbers, and as you get going at it, you won't need the graphic. You'll remember where to put them. But this will kind of help us organize ourselves to begin with. Okay, so the equation we want to factor is 3x squared plus 7x plus 2. We want to factor it into its two binomials. So a couple of things you want to look at first. Number one, you want to look at the n sign right here. So since that sign is positive, that means I'm going to have to add two numbers together to get a plus 7x. That's what it's telling us. So we're going to keep, and I'm going to show you how to do that, but you got to keep in your mind it's a plus, so you're going to add two numbers together to get a plus 7x, okay? So how we begin this process is take your first number here, which is a 3, and write down all the factor pairs for 3, and I'm going to put them in this box, so that's 1 times 3. And then x squared, what multiplies to give you x squared? X times x, okay? We could put it down below here, maybe I'll write it underneath here, so x times x. Okay, do the same thing on the back end. What are all the factor pairs of 2? Well, 1 times 2, that's it. Okay. So remember, we're going to try to get two things that add together to get us a plus 7, okay? A plus 7. So key here is that if it ends in a plus right here, then the two signs in your binomials are going to be the same sign. Okay, they're either going to both be positive or they're both going to be negative. And I know these are both going to be positive because I have to add them together, get a plus 7. So if the signs have to be the same and I have to add them together, get a plus 7, then they must have to be pluses. So I am going to put a plus sign right here in the middle, because I know that whatever I figure out down here, those two signs have to be plus. That's not guessing. I know that's what it's going to be. Okay, Now I'm going to try to figure out what number goes where. Now, I usually start with the first term, so this is really nice. I kept it prime. So there's only two factors here, a 1 and a 3 and an x times an x. You have to split the two factors. See how I've got this in a green box? One factor goes into one green box down here, and the other factor goes over here. This first step, it doesn't matter if you put 1, 3, or if you put 3, 1. It doesn't matter. That first one doesn't matter. You just have to put these two factors right here into the boxes. And now we have to do the same thing with the x's. We have to put one x in each box. So this is going to go x and x right here. Okay, so we've got our first set of numbers using our first factor pairs. We did a 3 and a 1, an x and an x. Okay, now it matters. My 2 can go, it can go 1, 2, or it can go 2, 1. I'm not sure. This is why it's a little bit of guessing and checking. So this method that I'm teaching you is called guess and check. There's lots of other methods, but this is kind of the one that I'll demonstrate in the class. So guess and check is what we're going to want to figure out. Okay, so you have to make a decision. So since I have a 2 and a 1 there, I'll just go ahead and leave it there. Now, the only way to figure out if you got it right is you have to check it. You have to multiply it out. Well, I know that 3x times 1x is 3x squared. And 3x times 1 is 3x. 2 times x is 2x. And 2 times 1 is 2. Okay, let's add those together. And what do we get in the middle right here? You get 5x. Is that what I wanted? No, I wanted 7x. Okay, so it looks like to me I put the 2 and the 1 in the wrong spot. So I'm going to switch places. I'm going to put the 1 right here and the 2 right here. Now, the first one doesn't change because I didn't move anything with the first one. So that was 3x squared. And now the last one will change to 3 times 2. So that's going to be 6x. And then I'm going to go 1 times x, which is x. And 1 times 2, which is 2. Add those two together. And we end up with 7x. So we have 3x squared plus 7x plus 2. Was that our original equation? If it is, and it is, that's our original equation, then the answer that we're after is this. This is what this binomial multiplication is: 3x plus 1 times x plus 2. So we factor that into its two binomial pieces. Okay, let's try another one. So notice this one looks very similar to the last one. My first inspection is I always check this sign, and it's an add, so I'm supposed to add to get a -7. Okay, well, I feel like that I could easily solve this question in that since I know it's an add, both signs have to be identical. So since I'm trying to add to get a -7, I guess they better both be negative signs. And just like on the first page, this is still a 1 times 3 and x times x. And these factor pairs over here are 1 times 2. Doesn't matter the order. I'll do the same thing we did on the other side. We did 3x and x. And then we put the 2 and the 1 here. Let's do a quick check to make sure that we've got everything in the right spot. So 3x times x is 3x squared. 3x times a -2 is a -6x. A -1 times x is a -1x. And a -1 times a -2 is +2. Combine our like terms. And did we end up with what we originally started with? We did. So what is this factor to? This factors to 3x minus 1 times x minus 2. Okay, so in this first example, we were kind of looking at the end sign here. It was positive, and so if this end sign is positive, that's really helpful. If this is positive, then I know these two signs down here are identical. Okay, they're either going to both be positive or they're both going to be negative. How do I know? It's whatever I'm going to add to. I'm going to add to be a negative 7, so they both have to be negative. Okay. All right, so now let's look at this one right here. This one says it's a subtraction sign. So if it ends in a negative, that tells me that the signs have to be different down here. So I can have a positive, oops. So it could go positive or negative, or it could go the other way. It could go negative or positive. Now, I'm not sure which way it goes, so I usually save the signs on this one till more towards the end. But what I do know is that they're both different, so one's positive or negative, and I'm supposed to subtract, since this is a subtraction sign, I'm supposed to subtract to get a negative 5. Okay, so when it's all said and done, I should be subtracting to get a negative 5. Okay, so I've kept these factor pairs pretty easy so that we can kind of see how to practice putting them in our binomials first. So this is 1 times 3 and x times x. That's our first term. Our last term is 2, so that's just 1 times 2. So remember, it doesn't matter this first parenthesis. I can put them any way I want, so I think I'll go 3x and x. Okay, now it matters. I've got to put a 2 and a 1, and I want it to subtract to be a 5. Okay, so this is kind of what I do. I'm going to put these two numbers close together so you can see. Oops, I don't want that one. This is kind of some mental math that I do in my head. I go 1 and 3 and 1 and 2. Okay, so one number from the left over here has to multiply with one number from the right over here. So for example, I could take the 1 times the 1 and multiply them together. So 1 times 1 is 1. And then what I do is I multiply the other two together. So I do 3 times 2, and that's a 6. Is there any way to subtract a 1 and a 6 to get a negative 5? Well, there is. If this is a negative 6 and I add 1 to it, then it's going to be negative 5. Okay, that told me, that little mental work, I usually kind of do that in my head, told me where to put the 1 and the 2, so it's not a random guess. I mean, I could put a 1 here and a 2 here, multiply it out and check it, and if it's wrong, then I'll just reverse places. But if I do a little bit of work ahead of time, it saves on the random guessing. So how did that work? We wanted the 3 and the 2 to multiply together. So if you want the 3 and the 2 to multiply together, they cannot be in the same parenthesis. So meaning 2 can't be here because there's no way it can multiply with the 3. So I know then that it has to go 1, 2. And we wanted it to be a negative 6, right? So we want the 2 to be negative, and we want the 1 to be positive. Okay, let's multiply it out and see if we did it right. So 3x times x is 3x squared. 3x times negative 2 is negative 6x. 1 times x is 1x. And 1 times negative 2 is negative 2. Combine your like terms. 3x squared minus 5x minus 2. Was that our original problem? Yes, it was. We did it right. So this factors to 3x plus 1 and x minus 2. That's what it factors to. Okay, let's try another one. So once again, first thing I do is I check this n sign. It's a subtraction. So that means my signs are different. I've got a positive and a negative sign. When it's all said and done, I subtract to get a plus 5. So I feel like it's basically the problem before, except we switch the signs. This would be, our factor pairs are 1 and 3, x and x. This one over here was just 1 and 2. So if I go 3x, x, and I put the 2 and the 1 like we had last time, I want a plus 5, so I think I'm going to make the 6, the 2 times 3, the 6x, I'm going to make that positive, and then the 1 times x is going to be the negative. Okay, let's multiply it out and see if that's right. 3x squared plus 6x minus 1x minus 2. So does that give me a plus 5x? It does. So that factors to 3x minus 1 times x plus 2. Okay, so let's try it again. Um, so this one, different numbers now. So now that we understand the end sign, we can figure out how to do this. So quick look here tells me it's a plus. So I know both my signs are identical. And what are they going to have to be? They're going to have to be something that adds to be a -7. So no guessing here. I already know. I love it when it ends in a plus because I already know what those two signs in the parentheses are. I don't have to figure it out. They have to be identical. And since I have to add to get a -7, they both have to be negative, right? That's the only way to get a -7 if both signs are identical. Okay, so now I'm going to do my factor pairs. So for 2, I have 1 and 2 and x times x. And then for 5, I have 1 and 5. So remember, first spot, it really doesn't matter if I do 2, 1 or 1, 2. So I'll just go 2x and x. Okay, now it matters. I either have to go 5, 1 or 1, 5. And one of those is right and one of those wrong. So I do a quick little mental check right here. So 1 times 2, and I do 1 times 5. And remember, I've got to multiply 1 from, so I'm going to do 1 times 1, and that's going to give me 1. And then I'm going to do 2 times 5, and that's going to give me 10. So is there any way to add those to get a 7? Probably not. Okay, so that's probably not the combination I want. So I'm going to do another quick check. So I'm going to go, I did 1 times 2 and 1 times 5. So first time I did 1 times 1. So this time I'm going to do 1 times 5. It doesn't have to be first number to first number. It's just got to be one number from the first factor pair times one number from the second factor pair. So 1 times 5 is 5. And then I'm going to do 2 times 1, which is 2. Okay, can I add those together to get a -7? I sure can. A -5 and a -2 give me a -7. Okay, so how did we want that to work? We want the 1 and the 2 to go together and the 5 and the 1 to go together. So I don't think this is the right way. Let's put the 5 here so that it can multiply by a 1, and then the 2 can multiply by 1 here. Okay, now instead of multiplying the whole thing out, this little mental check that I've been doing right here also matches what I call a quick check down here. So my quick check is normally when we do multiplying, we do these 4 terms, right? These 4 patterns here. Okay, the 2 of those patterns that multiply to give us the middle term is this one right here, this parenthesis, and this parenthesis. Those two, when I multiply those two, that always gives me the 2 middle terms. So instead of doing all 4, I'm just going to do these 2 right here. Okay? So watch, this is what I call the quick check. So if I just do 2x times the 1x, that's a -2x. And then if I do the 2x over here times the 1, oh wait, what was that supposed to be? That was supposed to be a 2, it's supposed to be a 5. Sorry, I erased it and then I didn't put it back right. This was supposed to be a 5. Let me redo that. So -5x. And then this one right here is a -2x. See how those two added to -7x, which matches this, matches what I was thinking up here in my mental work. Okay, so that's what I call the quick check. All right, let's try it again. So this one right here, it ends in a negative. So I know my signs have to be different. One has to be positive, one has to be negative, and they have to add to give me a +6. Okay, so we're always trying to get the middle term. Yeah, I don't know which combination to use yet. So I'm not gonna. unfortunately, I don't know what if it goes positive, negative, or negative, positive. That's why I like the plus sign, because you already know what the signs are. This one I don't. I'm going to have to do a little bit of work. So let's do our factor pairs. So 1 times 5, x times x. And then over here, we're going to have more than one choice now. 1 times 8 and 2 times 4. Okay, so remember, this one there's only one choice, 1 and 5. So it really doesn't matter how I put them in since there's one choice. So I'm going to use that combination. Okay, so over here in my head, my mental math looks something like this. Now, I've got to pick one factor from the left with one factor from the right. And now you can only pick them in. I can either work with a 1-8 pair or the 2-4 pair. You can't mix the numbers. It can either be 1 and 8 or 2 and 4. So if I don't have any idea, sometimes I look up here to see what the number is. 6x, that kind of seems like that's close to all the numbers that I have there. So I would probably pick the factors that are closest in numbers. So I think I would pick 2, 4 and 1, 5. Okay. Now remember, we're trying to subtract to get a 6. So we've got to pick something from this side. So I think I'm going to do 1. I usually just force a habit. 1 times 2. That's 2. Okay, now do the other one. 5 times 4. That's 20. Can you subtract to get a 6 out of that? No. So that can't be the right order. So let's take that out. So let's do, instead of doing 1 times 2, let's do 5 times 2. Okay, so 5 times 2, that's 2 I'm going to do. 5 times 2, so that's 10. And then I'm going to do 1 times 4, which is 4. Can I subtract those to get a 6? You bet. If this is a negative and this one's a positive, then I'm going to have my right answer. Okay, so now we've got to put in, so I know I'm going to use the factor pair 2, 4. So which one needs to be positive and which one needs to be negative, and where do the numbers need to go? Remember, the 5 and the 2 right here have to multiply together, so they can't be in the same parentheses. So I know the 2 has to be here and the 4 has to go here. Okay, and then we want it to be a -4, so I'm going to put the negative sign here and the positive sign here. I'm going to do a quick check to make sure I have it right. So remember, our quick check is this term right here in our multiplication, so that's a -4x, and this term right here. And usually I'll just usually kind of do a little arrow down at the bottom instead of the top. And so then we'll do, that'll be 5 times, oops, I erased my numbers again. So this one's a 4, this one's a negative, and this is a plus. So 5x times 2 is plus 10x. Add them together and you get 6x. And yay, we're happy. If you look, see our quick check. Here's our smile. We're happy. Here's the little guy's nose, and here's his eyes, if you want to think of him as a happy face. We're happy. We did it right. We wanted a 6x. Okay? So, what does that factor to? Our answer is 5x minus 4 times x plus 2. So to get good at factoring, you just have to practice. The more you practice, you start to see the number combinations. So all this mental math that I'm writing down, you actually do this in your head. You don't have to write it down. You get pretty good at it. Okay, let's try another one. So first thing I always do, inspect. That's a plus. So I'm happy because I already know what my signs are in my binomials. I have to add to get a -10. Well, the only way to add to get a -10 is if these two signs are identical and they both got to be negative. So I like it when it ends in a plus. Okay, so now let's see, what do we got for factor pairs here? Well, this is just an x times an x because it's 1 times 1. And then on the end, okay, we have a few more. We've got 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Okay, so remember, what are we trying to We're trying to add to get a negative 10. So since this factor pair over here on the left is just a 1 and a 1, basically this is the easy version. All you got to do over here is look at the factor pairs over here. Out of that set, which set could you add together to get a negative 10? Well, I'm thinking it would be these two right here. This would be -4 and -6. Okay, let's do a quick check and see if we got it right. So here's a -4x, and then here's our x times -6. So -6x, add them together, -10x. Is that what we wanted in the middle? Yep, we're happy. So our answer is x minus 4 times x minus 6. Okay, again, it's just practice, guys, over and over again. So let's see. I'm looking right here. It's a plus, so I have to add to get a plus 13. The positive signs make me happy because I know these signs already right here. I don't have to do any work. I already know it's positive, positive. Okay, so now I'm going to put my factor pairs in. 2, the only factor pairs of 2 are 1 and 2, and the only factor pairs of x are x and x. 6, I've got 1 and 6, and 2 and 3. Okay, first one doesn't matter. There's only one choice, 1 and 2, and x and x. So I'm just going to go 2x and x. Okay, so remember, we're supposed to add to get 13. So 13 seems kind of big. Normally, I would pick 2 and 3, and I'd try to get those to multiply together. And if I did that really quick, I could do 2 times 2, which is 4, and 1 times 3, which is 3. That's 4 plus 3 is 7. That doesn't work. And if you switch the order, 2 times 3 is 6, 2 times 1 is 2, 6 plus 2 is 8. So that's what I do in my head. That's what I call the mental math. That's the stuff that I was writing down. I quickly do that in my head. So 2 and 3 actually isn't going to work. It's actually going to be 1 and 6. Right off, 13 is kind of big. 2 times 6 is 12. That's getting us closer to the 13. So we're going to need to use the 1 and the 6 and the 1 and the 2. So I want the 6 and the 2. So in my head, my mental math looks like this. 1 times 2 and 1 times 6. I want the 1 and the 1 to multiply together because that will give me 1. And I want the 2 and the 6 to multiply together because that will give me 12. And 1 plus 12 is 13. So remember, if I want the 2 and the 6 to multiply together, they can't be in the same parentheses. So that means the 6 goes here and the 1 goes here. Let's do a quick check, make sure we got them in the right spot. So 1 times x is 1x. 6 times 2x is 12x. Add them together, and what do we end up with? 13x, and it's a plus. You got to make sure that your signs are matching. And we're happy because that's what we wanted. Does that give us a positive 6 on the end? It does. So everything's matching. So this factors to 2x plus 1 times x plus 6. Okay, again. So 5x squared minus 8x minus 13. So first thing I notice right here, darn it all, it ends in a negative sign. So that means my signs down here are different. One's positive and one's negative. I don't know which one is which yet, so I'm not going to write them down. I'm going to figure that out here in a minute. So my factor pairs are 1 and 5, x and x, and over here I've got 1 and 13, right? So I've just got to figure out what order they multiply together so that we can subtract to get an 8. Okay, so it doesn't matter. I'm going to put my 5x here and my x here. That first one doesn't matter. Okay, so what I'm doing, my mental math looks like this. 1 and 5. And, oops, here, let me do this. 1 and 5 and 1 and 13. Okay, if I did 1 times 1, that's 1. And then 5 times 13 is, what is that, 55, 65? So is there any way that it's going to subtract to give us an 8? I don't think so. So I think that it's got to go 1 times 13 and 5 times 1. So, and I want the 13 to be a negative. So a negative 13 plus a positive 5 would give me a negative 8. Okay, keep track of that. We want the negative 13 to be negative. So when I come down here, remember, I don't want the 5 and the 13 to multiply together. So I'm going to put the 13 here and the 1 here. It's our factor pair. Okay, we got to fix our signs. We want the 13 to be negative, so I'm going to go negative and positive. Let's do a quick check just to really make sure that we did it correctly. Negative 13 times x is negative 13x. And then 5x times 1 is plus 5x. Add them together. Do we get a negative 8x? We do. We're happy. Everybody's smiling. So now we know that factors to 5x minus 13 and x plus 1. Okay, again, so this time looks like x squared is going to be x times x. Factor pairs of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. I love it. It's a plus. I know that I have to add to get a plus 25. So this one I already know is positive, positive. 25 is a pretty big number to add to. So I think I'm going to try 1 and 24. So if first one is just x and x, and then 1 and 24. Quick check. That's a 1x. You don't have to write the 1. I'm just doing that so you can see where everything comes from. And then 24x, and you end up with 25x. Is that what we wanted, a plus 25? Make sure your signs are all matching. All the signs have to match your original equation. They do, so this factors to x plus 1 times x plus 24. Okay, what if on this one somebody had put the 24 where I put, what if you did it in reverse? What if you did this? And you put the 24 here and the 1 here. Do you still end up with the right answer? You do, so you end up with 24x plus 1x, and that's still 25. So the reason I'm saying it doesn't matter which one goes first is because x plus 24 and x plus 1, these are the same answers. They are identical. Remember, you can, multiplication is commutative. 2 times 3 is the same thing as 3 times 2. So the parentheses can be in a different order. What's inside the parentheses can't be different, but the parentheses can be in a different order. But if one parenthesis has an x plus 1, it has to be x plus 1 if you're writing it a different way. And same thing, the x plus 24 has to be in the other set of parentheses. So order doesn't matter, it's what's inside, okay? All right, so this one right here is a special case. It's called the difference of perfect squares, and we saw this when we multiplied out our binomials. What's happening here is that your middle term is a 0. So in our little setup, when we were trying to do our setup with our binomials, we're trying to add, this still ends in a negative, okay, so it still ends in a negative. But what's happening here is we're trying to add to what? You're trying to add to 0x. Really, this could be written like this. X squared plus 0x minus 16. You are trying to get this to subtract to be a 0x. I said add. You're subtracting here. This is a negative. So if you were to look at the factor pairs of 16, because I don't have the little graphic here anymore, but remember, we always start with factor pairs of the first one. We would go x times x, and then factor pairs of the last term, which would be 1 and 16, 2 and 8, and 4 and 4. Out of those factor pairs, if you're trying to get something in the middle as a 0, then everything has to be identical and have to be opposite in sign. So you can't make a 2 and an 8 work because there's no way to add a positive or negative of that to get a 0. So you know you're going to have to use the 4 and the 4 and the x and the x. Those are identical. Those are perfect squares. That's why it's called difference of perfect squares. So when you factor it, so you put an x in and an x in, you put a 4 and a 4, but what do the signs have to be if it ends in a negative, if it ends in a subtract? What did we learn from the other slides? They have to be different, right? So one's positive, one's negative. That's what this up here is telling you. Difference of squares multiplies to two parentheses. They look really close. The only difference is that they have one's a positive sign and one's a negative sign. Okay, so let's look over here to the one m squared minus 81. So this is m times m, and 81, I'm just going to do 9 times 9. I know I'm supposed to be subtracting to get a 0. So m, 9, 9. One has to be positive, one has to be negative. Quick check. That's a plus 9m. That's a minus 9m. Do those two add together to give you 0m? They sure do. There isn't a 0m, so that's what it factors to, m plus 9 and m minus 9. Okay, down here, this one's not a 1 anymore. This is a 4's got a 1 and a 4, and a 2 and a 2, and then x squared is just x and x. Okay, and 9 has got 1 and 9 and 3 and 3. But remember, you're trying to get a 0 in the middle. You are trying to subtract to get a 0. So that means all the factor pairs have to be identical. So you're going to have to use this one, and this one. If you're trying to get a 0 in the middle, you have to use identical factor pairs. So when I go and set it up, my 2 goes here, x, 2x, and then the 3 and the 3. Because we're subtracting, the signs are different. Quick check. This would give me a plus 6x, minus 6x. Add them together. Do we get the 0 in the middle? We do. So that factors to 2x plus 3 and 2x minus 3. Okay, here's some more to just end with as a practice, and then I think that's it. So we've got 4 here without the graphic. So what I do is I just write the little factor pairs right underneath when I don't have my graphic. So 1 times 12, 2 times 6, and 3 times 4. Okay, I put my parentheses down here. 1 and 5 is my only choice, so I'm just going to go 5m and m. Okay, it ended in a negative. Did you notice that? So it ended in a negative, and they have to add together to give me a plus 17. So I think I'm going to try 3 and 4 first. So my mental math is saying this. 4 times 5 is 20, and 3 times 1, so that's 20, and 3 times 1 is 3. Can I subtract those to get a 17? I sure can. This would be a plus, and this would be a minus. So we want the 4 and the 5 to multiply together. So the 4 is going to go here, and the 3 is going to go here. I want it to be a plus 20. Okay, let's just do a quick check and make sure we got everything in the right spot. Minus 3m plus 20m. Does that give me 17m? It does. So this factors to 5m minus 3 and m plus 4. Okay, over here on the right, we have 1 times 2 and n times n, and then 1 times 7. Nice. It ends in a plus. I love it. We're going to have to add to be a plus 15. So right off, I already know what my signs are. So this is going to go 2n and n. You have to pick, there's only one factor pair, the 1 and the 2, and then the n and the n. Okay, so I've got to get a 1 and a 7. Now remember, I want to get a 15. So hopefully you were recognizing, ooh, 2 times 7 is 14. That's getting us close. So I'm going to put the 7 here, the 1 here. Both signs have to be positive. Let's do a quick check. 1n, 14n, 15n. That's what it should be. That's our answer. 2n plus 1 times n plus 7. Perfect. Okay, down here, this one's a little different in that we have more than one choice for our first factor pair. That hasn't happened before. So now we're going to have to think, do we want to use 1 and 4 or 2 and 2? So a little bit of mental math. It ends in a plus, so we know, and we got to add to 8. So I know since I'm adding to 8, it's positive, which is really, really nice. So off the top of my head, doing a little bit of mental math here, I'm looking at these two, 2 and 2 and 1 and 3. 2 times 1 is 2 and 2 times 3 is 6. I could add those together and get 8. So that's the combination I want to use. I'm going to go 2m, 2m, and then 1 and 3. So quick check, 2m, 6m, add together, is it a plus 8m? It is, that's what I wanted, so that's what it factors to. Okay, and then our last one here, we have factor pairs n times n. 16 is 1 times 16, 2 times 8, and 4 times 4. Okay, so notice n's in a subtraction, so I know the signs have to be different, and I want it to subtract to be a negative 6. Well, this first one is n and n, so that's really not going to matter because I don't have anything to multiply. 1 times anything won't change its value. So I'm just going to look over here. 116, 2 times 8, and 4 times 4. Which one of those factor pairs would subtract to give you a 6? It would be the 2 and the 8. Okay, so when I set my binomials up, I'm going to go n and n, 2 and 8. Now I want it to be a negative 6. So I want the 8 to be negative and the 2 to be positive. Let's do a quick check. That's a plus 2n. It's a minus 8n. Add them together and you get a negative 6n. Is that what I wanted in the middle? It is, so that's what it factors to. So this guess and check takes a little bit of practice. You will get good at it. Some people see the number patterns right off. Their mental math is really good. They see the number combination and it's really easy for them. Other students have to work at it a little bit, but I promise you everybody will get better at it. This is one of the big ideas for Math 2. You have to know how to factor. It will not go away. Math 2, Math 3, any math class from here on out, you have to know how to factor. It's almost as like combining like terms when you learn to add or solve for x. It's that basic. It's used in so many classes. So if you didn't get it figured out from the video or in class, come in, get some help. It's not going to go away. You have to know how to do this. Like I said, there's other methods. So if you're really, really having a hard time with this guess and check, there's other methods that you could try. I will demonstrate in class with the guess and check. So that's why I would prefer you learn that method. But if you can't get this method down, there's others. I could show you a couple others that maybe might work better for you. But factoring is super important and you have to know how to do it.